Performing analog input is one of the most requested functions of the USB 6009. With 8 analog input channels, you can acquire quite a few signals. The total throughput rate of the device is 48,000 samples per second. So if you are acquiring all the time on all channels, you could have up to 6,000 samples per second per channel. So let's set up our acquisition to acquire on one channel at 1 kilosample per second per channel. But first, I would like to show you the setup that we have here. This is the USB 6009, and I have a potentiometer hooked up to it. I'm taking the 5-volt output of the 6009 that's going into the potentiometer, and coming out of the potentiometer is our analog signal that we'll be reading on our analog input channel 0, and then we have ground coming from the potentiometer to the ground of the 6009. So now what we're going to do is switch over to LabVIEW. And LabVIEW is our graphical programming language that lets us set up data acquisition tasks quickly while still preserving flexibility. And you can download the LabVIEW evaluation version at www.ni.com. So I'm going to open a blank virtual instrument, or a VI. And on our front panel, I'm going to click right, and I'm going to put a waveform chart on the front panel. So we choose that, we stretch it out to the size that we want it to be, and then we're going to set the scaling on this. Now, my potentiometer is being powered with a 5 volts range, 5 volt level, so we're going to have 0 to 5 volts coming out of it. I'm also going to tell it not to auto scale because I want to make sure it doesn't change that scaling while I'm running the program. So next we'll switch over to the block diagram. And here in the block diagram we can see an icon of our waveform chart. What we're going to do now is set up our data acquisition by clicking the right mouse button, going to Measurement and I/O. We'll go in and choose the DAC Assistant, and we'll put it down on the diagram. Now the DAC Assistant automatically opens up and starts asking us questions and letting us make selections. And we want to acquire signals, analog input, we want to set up a voltage, and then we want to choose our analog input channel 0 because that's where our measurement's coming from. We'll click Finish, and we can specify some things about this reading now. Our device is set up to be plus and minus 10 volt range, so we'll specify that right here. Next, we're going to tell it our terminal configuration is single-ended or reference single-ended. And then finally, we're going to choose continuous sample, and this simply means there'll be no gaps between our data. We'll say OK. It's going to go and build the function now, and at this point it's going to ask us one more question. It's going to say, would you like to do this continuously in a loop? And the answer is yes. So I'll choose yes, and it automatically places it inside a while loop. Now I'll take the waveform chart, I'll put it also inside that loop so that it's updated continuously, and then I'll take the output and I'll wire it up into the graph, or my chart in this case, and we're ready to go. We'll go back to the front panel and we're going to run the program. So at this point we see that our data is being collected and it's displayed on the screen. I'm going to reach over and I'm going to turn the potentiometer, and you're going to be able to see that signal changing now, and it's changing with my motions on the potentiometer. So there we've built a program, we've acquired our data, and we've displayed it on the screen, and we've accomplished our analog input task with our USB 6009.